Hello friends, this video on chemical bonding part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. Transfer of electron, as I told, is a electrovalent bond. So as I told that the negative ion from a halogen like chlorine, fluorine, they form a negative ions, and the positive ions from the alkali like sodium, potassium, right? Because these guys easily lose electron and form a positive ion, and these guys halogens easily get electron to form a negative ions, and they form positive and negative ions, and these ions are held by electrostatic attraction. Example I told here, sodium had 1 electron, chlorine had 7. It gave 1 electron to chlorine, sodium becomes Na plus, and chlorine now got 8 electrons, 1 extra electron got a negative charge in this, and then they are held by electrostatic attraction, correct? And these kind of bond formed is called electrovalent bond. Another example is CaCl2. Chlorine, calcium has 2 electrons in the outermost shell, chlorine has 7, this chlorine also has 7. This calcium easily gives 2 electron, 1 to each of the chlorine. Calcium gets positive charge 2 plus, and each of these chlorine gets a negative charge, and then they are held by electrostatic force of attraction. This kind of bond is called electrovalent bond, and Lewis approach is able to explain this kind of bonds, right? Just an example of sharing of electron. So again, this postulation was done in 1919 by abandoning the idea of cubical arrangement, which I explained. This was a theory he gave, but again this theory was redefined in 1919 by Langmuir, similar to what we have example of the teacher redefining the theories about the student getting less marks. This theory was redefined in 1990 by Langmuir, and he told that the covalent bond is formed, and how it is formed is, for example, this is chlorine to chlorine, both has 7 electrons. Nobody is willing to give electrons, so they will share this electron. This chlorine assumes that it has 6 plus to 8 electrons. This chlorine assumes it has 6 plus to 8 electrons, right? Because these electrons shared. So this is the theory given by, this is a Lewis theory which explains the bonding, correct? And please note, in this case both the chlorine has got the noble gas configuration. And there are some rules for the covalent bond condition. It's pretty simple, actually, the same thing which we explained earlier also. So it says that each covalent bond is, I'll write word covalent here. Each covalent bond is formed as a result of sharing of electron pair, correct? And each atom should contribute at least 1 electron to the shared pair. And these combinations, all the sharing happens just to attain the noble gas configuration. I told energy is like a stress. These guys had more energy and they want to release the stress, release the energy to attain the stable gas configuration. Everybody in life wants to be stable, right? So that's why the same thing with this atoms also, they want to be stable, and that's why they form this bonding. That is what this theory says. And if you see, for example, water, if you see the way it works is, I'll explain the water to you. Water looks like this. So hydrogen, so oxygen has 6 electrons, hydrogen has 1 electrons. The way it works is, this atom is shared. Now I'll put star here. So this particular atoms, two electrons are shared between hydrogen and oxygen. So hydrogen thinks it has 8 electrons. Similarly, this guy thinks it has 8 electrons. And oxygen thinks it has 2 electrons. See, it is not always 8. For hydrogen it is 2, and for boron it is 6 to achieve the stable gas configuration. So hydrogen gets 2, it is happy because That's what makes hydrogen stable. Oxygen gets 8 now, 6 it had, and 2 it got shared from hydrogen. Oxygen also feels happy it got 8. And that's how the same thing is represented here. If you see, if I assume like this, the one with the dot is something which is coming from hydrogen, 2 hydrogens, cross is coming from hydrogen, and the one with the dots is coming from oxygen molecules. So oxygen had 6 dots and 2 cross, 2 from hydrogen. Similarly, if you see CCl4, so I'll put all the one coming from carbon as cross. So if you see, carbon had 4 electrons, the one with the cross. Chlorine had 7, the one with the dots. This also had 7, all 7. Now, this chlorine shared this electron with this carbon, so it got 8. Similarly, this chlorine also shared, it got 8. This chlorine also shared, it got 8. All these chlorine got 8 electrons, the outermost shell, and they are stable. And this carbon also, it got 8 electrons. How? Because these 4 electron pairs are actually shared. Correct? Because in this pair, if you see, 1 electron comes from carbon, 1 from chlorine. In this also, if you see, 1 comes from carbon, 1 from chlorine. Here also 1 from chlorine, 1 from carbon. Here also 1 from carbon, 1 from chlorine. And that's what this thing is, right? So each covalent bond is a result of sharing of electron pairs. And in this one pair, 1 electron comes from, each atom contributes 1 electron to a pair. So it's not that both the atoms come from this carbon. So 1 comes from carbon, 1 comes from chlorine. Here also if you see, 1 comes from oxygen, 1 comes from hydrogen. 1 from hydrogen, 1 from oxygen. These are the shared pair. Correct? Lewis' approach also was able to explain double, single, double and triple bond. It was able to explain this double, single and triple bond. It says that when 2 atoms share 1 electron pair, they form a single bond. When they share 2 electron pairs, they form double bond. And when they share 3 electron pairs, they form triple bond. So if you see in this case, I'll put cross for the atoms from electron from hydrogen and dot from the atom from oxygen. If you see in this case, only 1 electron pair is shared between oxygen and hydrogen, right? So this is the single bond. So in this case also, if you see, carbon has 4 electrons, hydrogen has, let's put star here. So in this case also, if you see, there is 1 electron pair shared, right? In this electron pair, 1 electron each from carbon and hydrogen. So there is a single bond, right? Only 1 electron pair. So there is a single bond. For CCl4 also, if you see, this is the 4 electrons from carbon, and this is shared with this chlorine, right? There is a single electron pair shared. If you see, there is a single electron pair. So it's a single bond. In case of ammonia also, if you see, nitrogen has 5 electrons, so 3 here and 2 we can already see, and it shares single electron pair with hydrogen. If you see, there is a single pair share. So it's a single bond, right? Here if you see, ethene, so if you see, carbon has how many? 4. So 1, 2, 3, 4 electrons. Here also 4 electrons. Correct? So if you see here, between carbon and carbon bond, how much they are sharing? They are sharing 2 electron pair. Between carbon and carbon bond, if you see, there are 2 electron pairs getting shared. I'll just show you. This is how it is shared. So this is how it is shared. So this carbon assumes it has got 4. You see, it gets 2 electron from hydrogen actually, right? So this carbon, if you see, it gets 8 complete. How? 4 it had, 5th it got from its hydrogen, 6 it got from its hydrogen, and 2 it got from this carbon. So there are 2 electron pairs shared. So it is double bond. Correct. Here also if you see, there two electron pairs are shared. See, oxygen had 6. Now, for oxygen to get complete octet, what oxygen will do is it will take 2 electrons from carbon. Right? So, 2 electron pair is shared between carbon and oxygen. So, it's a double bond. Similarly, if you see for triple bond, 3 electron pairs shared, because if you see nitrogen had 5 electrons. This guy also 5 electrons. So for it to complete octet, it needs 8 electrons. So what it will do? It will share 3 electrons. So if you see, these 3 electrons are shared. Since 3 electron pairs are shared, it is triple bond. Correct? For example, in this case, ethane also, if you see, carbon, it shared 3 electrons with this carbon, 3 electrons pair. So it is a triple bond. Correct? So it's 1 electron pair in this here, it is single bond. If it share 2 electron pair, it's a double bond. If it share 3 electron pair, it is a triple bond. So Lewis' approach was able to explain the bonding, why it is double bond, single bond, or triple bond.
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.